Hi guys, my name is Ivo and I'm from mytestedasp.net. In my previous videos I showed you how to create very fast new objects with expression trees, and currently I'm going to show you how to optimize property getters with expression trees. And I'm influenced by the ASP.NET Core framework, which essentially needs to optimize uh, some of the property getter calls. Let me show you what I have in mind. So quite often in ASP.NET uh, web applications, you write something like return redirect to action. You say the action name and then you provide values as an anonymous type. So essentially what ASP.NET needs to do, it needs to get from this anonymous type a dictionary which contains the name of the property and the value of the property, and the name of the other property and the value of the other property, that's a dictionary, which is quite easy to be done with reflection. You can just get the properties of this object and then you can generate the dictionary from them. But this call needs to be done on every single request. So for one web server, that request may be done like a million times and more. For each request, we need to get the properties. And if we use reflection, that's slower. We should use a better approach. As a matter of fact, I already showed you in my very first video in this channel, which is optimizing reflection, the actual implementation from the Microsoft's source code. So if you want to see how to do it with pure reflection, make sure you check that video. But now I'm going to show you how to do the same thing and improve the performance of this object to dictionary transformation by using expression trees. The expression tree solution is fast enough, it creates delegates, but the best approach will be from the other video I already told you. So let's see how to do it with expressions and make it as fast as possible. The downside of the expression trees is that it uses a little bit more, they use a little bit more memory. Let's do it fast enough. First, let's use system diagnostics because I would like to measure the slow version and the fast version. As you know, you may know, I'm not sure, but you may know that BenchmarkDotNet is the ultimate tool for performance benchmarks. I'm using stopwatch for the sake of simplicity. It's good enough, but if you want perfectly on-point measurements, use BenchmarkDotNet. Okay, great. So I'm going to create 10,000 dictionary transformations, dictionary string to object. my object will be this one. Great. Okay. And by using reflection is kind of simple. Object dot get type, get properties. For each property, I'm going to use link in both solutions, so link will not be the problem with performance. Property, I would need to get property dot name, and value, it will be property get value from the object itself. Then I'm going to say to list, and I'm going to for each property, and I'm going to save it into the dictionary like this. Then afterwards I'm going to stopwatch, whoops, a reflection property getters, and I'm going to write down the dictionary.count just to make sure that the compiler is not optimizing the call here. Then I'm going to restart the stopwatch, restart the dictionary, and I'm going to write a solution with property helpers by using expression trees. Good. So expression stopwatch is new. Okay, so what I'm going to create now, I'm going to create a new property helper class. The property helper will have the name and the value of the property I'm going to get, and I'm going to create public static property helper array get properties by a given type. So essentially my idea here is to say something like this needs to be func of object, and this will be the getter of the getter. Essentially that will be a function which will allow me to which will have the following signature: object.property. So I'm going to create with expression trees a function which will get the property for me, and I will provide the object from which I will need the property, and I will get it as a result. That's the idea behind the getter. So essentially the idea is to say property helper dot get properties. I would need type object dot type like this, and then I'm going to say select and essentially reuse the same thing I have above, but this time I'm going to say property.getter from object. So it's the same thing as here, but I will not have the property execution of getValue, which is essentially the slowest part here. The only slow reflection code here is the getValue from the object. So I will improve that. And I'm going to improve that by creating an expression tree. So, okay, first, there's a little bit of problems here, but let's see them one by one. First, let's try to create the following function: object some object goes to object.property. First, I need a parameter, so I'm going to create a parameter. Var parameter equals expression.parameter. If you're not familiar with expression trees, and this looks quite difficult for you, I have a video which is called Expression Trees Are Not Scary, in which I do an introduction to the expression trees. Make sure you check it out. I'm going to leave a link in the description of this video. But and if you want me to make video series about expression trees, explaining them in detail, some sort of deep dive, let me know and I'm going to create that. So I will need a parameter expression of type of object, and I'm going to create it object. Like, I'm going to create the following function. So I'm creating an object. Cool. Let's then create the body of the lambda expression. That's expression make member access. Make member access allows me to get a property or a field, and make member access wants an expression here and member info. The expression is the parameter I'm going to call to make the member access on the object. So I'm going to provide the parameter, but I would need a member info. So I will need to get var properties equals type.getProperties, like this. And for each property in properties, I would need to create a property helper with a getter function. So I'm going to move that here. Okay, so now I have an object, and I will need to provide the property. So I'm going to provide it here. Great. This should contain this expression object.property. I'm going to return no for now, and I'm going to put a breakpoint to see what's going on. And oops, exception. I'm receiving an exception because property ID, if you remember, I'm trying to get this property, and I'm receiving property ID is not defined on system object, and that's correct. I cannot say something like object equals object and then say object.id. That's not a valid C# code, so that's why my expression is failing here, because in order for me to get the property, I need to have the anonymous type here. So unfortunately, I cannot use an anonymous type here. So what I'm going to do is I'm going to cast the object before using the property. The code should look like this. And so I'm going to create parameter convert expression. The idea here is to cast the object to the anonymous type so that I can use the property and it will be a valid C# code. I cannot do it directly and I cannot use generic types to save me from this problem because I don't have a type for the object. I won't be able to provide any kind of type here because it's anonymous. So if I had a type and if I don't want to work with anonymous objects, it's fine, but currently I'm trying to imitate the ASP.NET core functionality which allows you to use anonymous types, so we should cast the object like this. Okay, so what I'm going to do is I'm going to create this expression by calling expression convert. It will ask me what to convert. I will say I would like to convert the parameter object, and I'm going to give this type here. So essentially I'm saying convert the parameter here to the anonymous type. And let's see if that works. It not works because I'm still using the not converted parameter. And if I take a look, the body currently is working. It's converting the object to the anonymous type and then calls the ID property. Win, a small win. Okay, so then we need to create the lambda. We are going to have another problem in a minute, but let's create the lambda because everything works fine here. Now, my idea here is to say create that lambda function like this, and it should be fine. So I'm saying expression.lambda, which is of type funcObject because it should be object because I don't know what kind of property I'm dealing with. It may be string, it may be int, it can be anything, so I'm going to use funcObject. And I'm going to provide the body, which is the above. And I'm going to provide the parameter. Then I'm going to call compile, but I'm going to compile it. Property getter func equals lambda.compile. And essentially that's what I'm going to use for faster performance. And if I run it, I'm going to see another exception, and that's because the property ID is int and cannot be used for return type system object because the lambda return type is object, but the property is of type int. So what I need to do is I need to convert the body to an object. It gets a little bit ugly, but trust me, it works and it's fast, so it's completely okay. So I need to cast the result from the property to object, and the whole lambda expression should become like this. It's a bit strange, but when you're dealing with type safety, you need to make sure everything works fine. So expression convert, I'm going to convert the body to type of object. And since I'm using type of object more than once, I'm going to pre-cache it. Private static type of object. And I'm going to make it static read-only type equals type of object. I'm going to reuse that. So if I give the converted body to the lambda, it should compile now. Yay, we have a win. So let's test whether everything works fine. I'm going to return the property helper, and I'm going to return that as a to array. Great. Let's see whether that works correctly. And I'm going to hit a breakpoint here and see whether the dictionary has one saved value. And dictionary has ID 5 query text. Great. Very nice. It works perfectly. Let's see how fast that's not. It uses 3 seconds, and this uses 100th of a second because we are not caching, because we are compiling. And as you may already know, the compiling is the only slow operation here. So let's pre-cache that. Private static concurrent dictionary. I'm using concurrent dictionary because if you decide to use such code in a web server environment, each request is on a separate thread, and you have a concurrent environment, so all static caches should be in a concurrent dictionary. Concurrent dictionary, which will pre-cache the properties for every type. And I'm going to say that I have this cache, and I'm going to say cache dot get or add by this type, and this is the what we need here. And I'm going to use a better and shorter syntax. So essentially I'm caching all the properties for each type, which is kind of fine. And let's run it to see it again. It's still not fast enough. That's completely normal. Let's make more requests, and it gets faster and faster. So if I'm using a web server, for example, and I have 1 million requests in that web server, and I need to get the properties as fast as possible, I would prefer to use either expression trees or the reflection delegate method I showed in my previous video, but currently it's very fast. It's quite faster. Actually, it has more than 200% improvement. If I decide to see how much faster a single call on a pre-cached property helper request, I would have quite an improvement. So if you don't count the compilation, we have 10 times faster property getter. It's extremely fast. So expression trees and generating delegates from them are way better than using reflection directly. I pre-cached it, so I warmed it up, so this code starts behaving better. Again, what I did is I created a property helper with name and func of object getter, and when I get the properties, I cache them so that it will be faster. And for each property, I'm creating a function which allows me to access the property. Unfortunately, I cannot do it directly when I'm using object, so I need to cast the object to the type I'm going to use, currently the anonymous type, then get the property and then cast the result from that property to object and create the lambda expression from there. And this is how I got quite an improvement in the property getter. So guys, if you like the video, hit the thumbs up button below, leave a comment if you have any questions, and if you want me to make a deep dive for the expression trees, let me know. And that's it. I will be extremely thankful if you decide to support my projects or decide to support this channel. It will be very nice. Thank you and bye.